Hey there, chemistry. This is Miss Ruark again. I do apologize that the last podcast got cut off at the end of that problem, but at least we got to the end of that problem, right? That was a good thing. Okay, so I thought I would come back on here and just do this example for you real quick so you would at least have one of both of the different types, and then that way we can just be done. So this one will be a really quick vodcast. Okay, so this one says, example 2, calculate the freezing point for water if 320 grams of solid calcium nitrate is added to 2,500 milliliters of water. So this right here is going to be our solute, the solid calcium nitrate, CaNO3 2. Okay, we can go ahead and break this up. We know that this is an ionic compound, and because it has nitrate on it, when we put it in water, it is soluble. So it's going to break apart into calcium ions, and it's going to break up into nitrate ions. But guess what? We have 2 nitrate ions. Okay, so we're going to have this. So we can go ahead and figure out our I value. Our I value, there's 1 calcium and 2 nitrates, so our I will be 3. Okay, so we're just solving as we go, right? We're filling out the little pieces. Okay, we want to know what is the freezing point. So what's the new freezing point of this substance? So we're going to have to look for what the change in the freezing point is. We need I. Guess what? We've got it. We need our Kf value, which is going to be on a chart or given to you, and I'm going to give it to you. So our Kf value is 1.86 degrees Celsius over molarity. Okay, now I write it as 1.86 degrees Celsius times kilograms over moles. Okay, another way you could see it, instead of degrees Celsius, you could see it as degrees Celsius inverse of molarity. It's all the same thing. Whichever one you choose is your choice. Go for it. Okay. All right, so that's our Kf. We've got that. The only thing we're missing is our molality. Okay, remember, molality is equal to moles of solute over kilograms of solvent. All right, so we look in moles of solute. We have 320 grams of solute. Okay, well, that's not a big deal. We know how to go from grams to moles, right? Right, we do. So we're going to put the molar mass on bottom and 1 mole on top. And the molar mass of all that, I'm going to save it for you and give it to you, is 164.10. Okay, yes, you would have to do that on your own in another problem, but I'm just going to give it to you because, well, I can. All right, so 320 divided by 164, and when we do that, it ends up giving us 1.950, and there might be more numbers, but moles. Okay, so that's how many moles of our solute we have, calcium nitrate. Okay, but we're looking for molarity. And for molarity, we don't want just moles. We want moles over kilograms of solvent, right? All right, so our kilograms of solvent, our kilograms of the solvent would be 2,500 milliliters of water. Uh-oh, it says 2,500 milliliters. That's not kilograms, is it? Oh, Miss Ruark, you didn't show us this and you're messing us up. No, I promise I'm going to show you how to get there. Okay, in your problems, you probably won't come across one like this. I'll probably give you grams or kilograms in all of them. But if for some reason we have milliliters, like 2,500 milliliters, and we need to get to grams, we can use the density of the object, which is in grams per milliliter, and it will take us from milliliters to grams, right? So we just use our density. Well, the nice thing about water is the density of water is 1 gram per milliliter. It's so easy. 1 gram per 1 milliliter. So let's just set this up just so you guys see where the numbers and the units are going. We want milliliters to cancel, so we put that on bottom. We want grams in our answer, so we put that on top. And we know 1 gram is equal to 1 milliliter. Milliliters cancel, and this will end up being 2,500 grams. That was easy, right? Yes, I know. Okay, now we need to get from grams to kilograms, and you guys know how to do that. 1 kilogram is equal to 1,000 grams. All right, so we're dividing, so that ends up being 2.5 kilograms. Okay, so here's our solvent. We're going to plug that in down here. 2.5 kilograms and 2.5 kilograms. Okay, so now all we have to do is divide 1.950 divided by 2.5, and that ends up giving us 0.78 for our molality. Okay, so now we have I, we have KF, we have molality. So our delta TF is what we're solving for. The change in freezing point is equal to I, which is 3, times KF, so 1.86 degrees Celsius times kilograms over moles. And then we're going to multiply that by molality, which was 0.78 molal. Okay, and this is moles per kilogram, right? Right, so kilograms cancel, moles cancel, we're left with degrees Celsius in our answer. And when we do all that math, we end up with 4.352 degrees Celsius. But that's not our answer. That just tells us the change in temperature. We want the actual new temperature. So what temperature does water freeze at? It freezes at 0 degrees Celsius, right? Okay, remember when we change the freezing point, we make it go lower. So we're going to take that and subtract it from 0 because we want that freezing point to go lower, right? So now our new freezing point is negative 4.352 degrees Celsius, or you could just do 4.35 and that's fine too. Okay, there you go. I just wanted to make sure you saw this before you came to class. When you come to class, we will go through more practice problems for you. And then we're going to do an ice cream lab. Yay! All right, I'll see you then. Oh, hold on. I got something else. Ha, ha, ha. Okay, see you then. Bye.